Hello, class. We're going to start the next part here about controlling chemical reactions. So, being able to control a chemical reaction is extremely important because some chemical reactions are quite dangerous if they are uncontrolled. So, in order to be able to manipulate chemical processes for our own purposes, we need to be able to control them. So, that's what this section is about. So, first concept here we're going to talk about is concentration. Now, concentration is defined by the amount of one material in a given amount of another. Okay, and increasing the concentrations of the reactants will make more particles react. So basically what that means is when you have your reactants together, you want to make sure that you have enough of the reactants in the same place at the same time in order for it to start a chemical reaction. So if your reactants are highly concentrated, like 100% pure of one substance and 100% pure of another substance, then the likelihood of the reaction is going to take place is extremely high. But if you change the percentages, it may affect how the reaction takes place. So if you want to have a highly concentrated reaction, you have to increase the percentage of the reactants. Okay, so the next thing is stirring. This is common sense. All of you already know this, but if you stir chemicals together, you're causing them to come in contact with one another more frequently. So therefore, you're increasing the likelihood that the reactants will actually react, come in contact with each other. So stirring will help increase. The next one you have is temperature. Temperature, a lot of chemical reactions require temperature in order to start. Just think about cooking, right? So you want to change a raw egg into a cooked egg, you have to increase the temperature. So increasing the temperature will cause the particles to move faster. And once again, if the particles are moving faster, they're coming in contact with each other more often, increasing the likelihood that they will react with one another. If the particles move faster, they will have more energy too, and this will help lower the required activation energy. If you recall from the last section there, activation energy is the minimum amount of energy that you need to get a reaction started. Surface area is another concept that you probably already understand. Surface area is basically the area of the reactants that are coming in contact with one another. So if you increase the particles of a material that are exposed, the reaction can happen faster. Here's a good example here with the log. If you have a whole log over here, a whole log, here's our log. Right, here's our log here. Get my pen working. Here's our log, right? This log here has been set on fire, and if you've ever set a fire before, you know that it can either happen really fast or really slow. And you can see on the outside, this is the outside area here is the only part that's technically exposed to the fire here. So the surface area is just the outside area of the log. But if you were to take this log chop it up into many smaller pieces, you're going to increase the surface area. You're going to give it more opportunities to come in contact with the oxygen in the air, and therefore that combustion reaction will take place more efficiently because it has more opportunity to come in contact with the reactants. Catalyst is another concept that you probably are aware of. Those of you who took biology last year, you should be aware of this one. A catalyst is a material that increases the speed of a reaction by lowering the activation energy. Enzymes are a type of catalyst that your body uses in the cells that provide a place or a surface for reactions to take place. These are extremely important. They're very temperature sensitive too. So sometimes if the temperature gets too high, it can cause the enzymes to deform, and therefore they won't work anymore. So they also are used to used up in the reaction. So they're not used up in the reaction. Sorry. So they're not actually a part of the reaction. They're just helping the reaction take place. So catalysts are extremely important because sometimes when you require a lot of activation energy in order to get a reaction started, you have to add a catalyst in some situations in order to have that reaction to take place. And a lot of times reactions can't take place unless there is a catalyst involved. So biologically speaking, digestion depends on catalyst. Like your first catalyst that comes in contact with your food is the one in your mouth, saliva. That is a catalyst that helps start the breakdown of complex sugars into simple sugars in your mouth. So, inhibitors are another type of way to control chemical reactions. These are the opposite of catalysts. Inhibitors are used to slow down chemical reactions. All right. So most of you probably have heard of this guy over here to the right. This is Alfred Nobel. Alfred Nobel is the founder of the Nobel Foundation that hands out the Peace Prize every year. Mr. Nobel made his fortune on basically with the discovery of a certain type of inhibitors that slow down the process of nitroglycerin being extremely having low activation energy and causing many explosions. So nitroglycerin is a type of chemical that has a very, very low activation energy. Okay, nitroglycerin was a chemical that they were using to use in the construction of the railroads, and when a lot of countries are developing in the 1800s, they needed to, blow up mountains and these sorts of things in order to lay railroad tracks. So nitroglycerin was the chemical that they were using at that time. Nitroglycerin is an interesting chemical because it, like I said, has a very low activation energy, and oftentimes there was many accidents with nitroglycerin because it's extremely sensitive to heat and to vibrations. Even you could drop nitroglycerin, on a table and it would literally explode. And so, if you have this type of chemical, I hope you all would agree that these are not exactly very safe to work with. So Nobel was the first person who I think really came up with the idea of how to control nitroglycerin reactions, to introduce it to an inhibitor and to slow down the process. It was still being able to use for massive explosions, but it increased the activation energy, so in order to make it more stable. And so this chemical that he was able to develop, which is commonly called dynamite now, TNT, is a technical long name. Somebody could look up that and put it in the comments section here. What does TNT stand for? And anyway, so an inhibitor in this example is something that is going to slow down the process. So your first assignment here in this section here is you're going to use this graphic organizer here as a template for you to finish filling out. Okay, so you're going to describe how reactions are controlled by these 6 things. Okay, so you're going to create some kind of graphic organizer either digitally or on paper, and you need to not just copy down what's here, but you need to obviously add a lot more information there. Okay, so that assignment is posted on Schoology. All right, so moving on to TSW 6, forming solutions. Remember, we talked about solutions in the second unit, I do believe. Solution is when substance is dissolved in another, right? Usually the particles are so well mixed, you can't see them with a naked eye. Not usually, but always. That's one of the classifications of solution. You can't see the particles, right? So, technically there's two parts of a solution. You have a solvent and a solute. A solvent is a part of solution that's in the highest amount. It is the thing that dissolves the other substance, okay? And a solute is the part of the solution in the smallest amount. It is the thing that is getting dissolved. So from your little diagram here, you see, maybe this is water, and this is this little purple stuff, maybe food coloring, okay? So the water would be the solvent, and the food coloring would be the solute. And once you mix them together, bam, you got a solution. So water is often called the universal solvent because it dissolves most all substances, many substances actually, especially ones that are polar. It is responsible for a lot of your bodily functions and being able to live and function properly. So water is called the universal solvent, okay? Chemically speaking, there's three ways substances can dissolve, all right? And it all has to do with their chemical properties that we've learned. So if it's an ionic compound, once the solution forms, it's going to separate, into ions. So this process is called dissociation. So you have an ionic compound like sodium chloride, you put it into water, and literally what's going to happen is it's going to be pulled apart by the polar water molecules. Now remember, polarity is when you have a water molecule that is slightly positive on one side and slightly negative on the other. And so these chemically act like magnets. So when you have the sodium chloride ion, you have your sodium chloride, right? The water molecule is going to surround both of those ions, and it's literally going to pull them apart, okay? So how that works is you have your positive ion, your positive sodium here. It's going to be attracted to the negative side of the water molecule, and it's going to be surrounded. And when it gets surrounded like this, it literally gets pulled away from the chlorine ion. And vice versa over here with the chlorine ion, it's being surrounded by the positively charged ions. And you can see those here. So the water molecule is flipped on the opposite direction. And the positive is going to be attracted to the negative ion of the chlorine and therefore pull it apart. So when you put salt in water, this is how the water molecules line up around it. It's kind of cool. This is called dissociation. To disassociate means to not associate with something, not to be involved or around it. So this is what happens. The next type is called dispersion. All right, dispersion happens with molecular compounds. So these are only the nonmetal type of things, right? So molecular compounds break into smaller pieces and spread evenly throughout the solution. Think about it when you're having a lollipop, right? Lollipops are made out of 99% sugar, and sugar molecules are nonpolar. All right, so what happens is the water molecules, because they're nonpolar, they're going to come in contact with the sugar molecules, and they're going to start getting in between them all and breaking them down into individual pieces, okay? So remember, this one's different because the water molecules are not breaking apart per se. They're not breaking into carbon and hydrogen and oxygen atoms. They're still sugar molecules. They're still combined, but individually. So this is called dispersion. Another word for dispersion means to spread out, and that's what these guys do. The third one is called ionization. Ionization is when neutral molecules gain or lose electrons and changes chemically by a reaction of the solvent and the solute. And so this mostly happens in acids and bases reactions and other type of redox reactions. Okay, so you have a water molecule here, all right, comes in contact with hydrochloric acid. What's going to happen is the electrons are going to be taken away. Basically, your hydrogen molecule is going to form this molecule here, hydronium. We learned that in the last section here, and chlorine ion. So this is going to be a reaction called ionization. Not a reaction, sorry, a type of dissolving called ionization. It gets dissolved because it gets stripped of its electrons. So, properties of liquids, solutions. So, physical properties of a solution can differ from those of its solute and solvent in three ways. So, conductivity is one of them. And so, if you have ions that are dissolved in water, obviously it can be now conduct electricity. So, these are only for ionic compounds. So they're ionic compounds, if you remember, they don't conduct electricity until they're dissolved in water. So also, how some of the properties changes depends on the boiling and melting point. You've all seen that before. Here's an ice truck that is spreading salt on top of ice on the road here. Now remember, ice is a crystal. The water molecules are bound together here in a regular repeating pattern to form ice. Okay. Now, what happens when you introduce a ionic compound to ice, such as salt? All right. So what happens is the salt gets in between the formation of the crystals, and as you can see here, all right, the water molecules line up around the chlorine atom, and vice versa. They line up around the sodium atom. So when that happens, it prevents it from forming a crystal anymore. So if it can't form a crystal, it can't form ice. So this is why we put salt on the roads, because literally what happens is the water molecules get pushed apart by the ions, and therefore causes it to dissolve, all right? Basically causes it to melt. And so this is the reason why ice doesn't melt when you put salt on it. This is very beneficial to us here when we're driving most places in the world, not Bishkek, but they put ice on the roads when it's icy out. They put salt on the road, when it's icy out to help make it safer to drive on. Boiling point is another factor here that changes when you when stuff gets dissolved, shall we say. So the boiling point here, you have a chemical called antifreeze, all right? And you put this in water and it changes the properties of water chemically. So antifreeze, and it has anti-freezing properties and it has anti-boiling properties, actually. And so if you put this chemical in water and dissolve it, right, it increases the boiling point of water. As you can see, water is here. So if you put, let's say 70% antifreeze, right, you in a solution in the water, you can basically increase the temperature to 120 degrees before it will boil. Right? So this is a very important feature for when you're driving your car, because in the summertime you see a lot of these people. If you've ever been driving up in the mountains or driving to Caracol in the August, you see a lot of people pulled over with their car like this. A lot of times people only put water inside the radiator system of their car, and once it gets really hot outside, the car loses the ability to cool itself off, basically. And if the water inside the car starts to boil, you have this stuff going on here, steam. This is not good for a car. It'll cause it to stop working. So you have to put antifreeze chemical inside the solution. You've probably seen this at the gas station before, right? They're always selling this stuff out front. It's like fluorescent colors, like orange and green, these sorts of things. So it's good stuff. You have to have that in your car, otherwise you'll overheat. It's not good. In the wintertime, it's the opposite. It keeps it from freezing inside your car. So if it's negative 20 outside, if you only have water inside the contents of your car, you're going to have a dead car. Heat of solutions during the formation of a solution, energy is either given off or absorbed. Once again, endo or ecto. A lot of times when you mix chemicals together and they dissolve in one another, you do have some significant changes of energy, and energy is either given off or it's absorbed. We'll talk more about this when we come back to class. Last but not least, I hope so, factors that affect dissolving. So surface area, obviously, if you have a big sugar cube versus the sugar cubes that are all in the very small pieces, they're not linked together, you have a huge difference in surface area. So the ones that have the greatest surface area will dissolve the fastest. Stirring, when you're making your tea, you drop your sugar in there. If you stir it around, it'll dissolve faster. And if you have hot tea versus cold tea, if you have put sugar into hot water, it dissolves a lot faster as opposed to putting in cold water, which it doesn't dissolve very well at all. So, same as the other concept we talked about earlier. The more the particles come in contact with each other, the more likely, or the more efficiently, shall we say, they will dissolve or react with one another. So here is your last assignment. So you have 2 assignments for this section. I went ahead and filled out this graphic organizer for you. You need to use it as a base, and you need to add the descriptions of everything that we talked about today and have that turned in for me by tomorrow. I think you guys can work on this today and tomorrow. If you have any questions, please let me know.